recording.
C is if both improper integral, that is a2 and fx dx and lower limit negative infinity to b fx dx are convergent. That is, if we, when you find the integral, if we get a finite number, then we can find negative infinity to infinity this integral by adding these two. That is, so if you draw a real line, and here it is a, here it is b, so this means a to so no, it should be b here. A to infinity means this part, b to infinity is it's kind of like that. But we need to find negative infinity to infinity. This we are going to find by, we can say, negative infinity to a fx. Here it should be, it should be a here, sorry. Dx plus and a to infinity. So if you draw a real line, it's a. This means, this part means all this side. This means all this side. So negative infinity to infinity means whole real line. So that's why we can add this one and this part so that we can get the whole real line. So, okay, let's do an example for this to understand this one, because we didn't do any example. Evaluate negative infinity to infinity. Your integrand is 1 plus x squared dx. Okay, so let's say, let's assume a is equal to 0, because it is easy if we use a is equal to 0 when we are using the upper limit and the lower limit. If it is equal to 0, it is easy. That's why I chose a. And so it is convenient. Okay, so can you try to find, so to find this one, we need two parts. Okay, so that is, let's say, so the first part is negative infinity to a. So can I find this? We did this yesterday. And the other one is, so a is equal to 0. And the other one is when a is equal to 0 to positive infinity, 1 plus x squared dx. Can you take maybe 2 minutes, some time to practice this? You can use the definition which we use in A and B. So let's find first this part. How do we write this in limit? That's the first step. So you should write this in limit, because here it is negative infinity, so it's an improper integral. So first you have to write it as a limit. So I'll write it, it's just limit. I'm introducing t. T approaches to negative infinity. And here we have p. 0, 1 over 1 plus x squared dx. Okay, so what is the antiderivative of 1 over 1 plus x squared? Tan inverse, yes, arctan. Good, very good. Tangent, so arctan, so it is tangent inverse, tan inverse. So we can write tangent inverse x, okay, and then we apply the limits t and 0. So can you all find now? So if we apply limit t goes to negative infinity, it is tan 0 minus tan inverse t. Okay, what is the answer for this? What is the answer for this? Infinitive, let's see, others. So, I hope tangent theta is equal to some kind of like a value. So here it is tangent 0 and tangent theta is negative infinity. So, okay, so what is tan inverse 0? When do you get theta? It's 0. Yes, so tan inverse 0 is 0 minus limit when t goes to negative infinity t. So what is the angle when this t is equal to negative infinity? What is the angle? So it's like if you write this is when do you get tangent theta is equal to negative t? What is the value of theta? What is that angle? That's the idea. So if you remember the tangent graph, basic graph, it will look like this. This is pi over 2, this is pi over 2. Yes, good, Matthew. It's negative pi over 2. So if you remember, this is the basic graph of the tangent. So this is tangent theta. Okay, so this is negative pi over 2. So to get to negative infinity, that means your angle is negative pi over 2. Okay, that's how you get negative pi over 2. Okay, so then this is equal to 0 minus negative pi over 2. So that is equal to pi over 2. Okay, so we have now, so this means this is negative infinity to 0, 1 plus x squared dx. We are not done yet because we need to find the other part. So that is 0 to positive infinity, 1 over x squared dx. Okay, so like what we did here, can you find what is the value of the value of this improper integral? So if I write it as a limit goes to t goes to infinity. Here it's 0 to t, 1 over x squared dx. So it's the same thing what we did in the last one. Yes, pi over 2. So how do we get others? What about others? Let's wait for others. Already pi over 2. Okay, so we have a couple of formulas. So let's see. So t goes to infinity. So this one, again, it was tan inverse x. And you have to, lower limit is 0, upper limit is t. Now limit, don't forget t is go to now infinity. So it is tan inverse t minus tan inverse 0. What is tan inverse 0? It's just 0. So what is this one? This part, limit of tan inverse t. Don't forget now t is goes to positive infinity. By looking at the graph, but yes, Mark, yes, it's pi over 2. By looking at the basic graph, look, if t goes to positive infinity, that means this part. It goes to positive infinity. So then what is the angle? That is pi over 2. So it is pi over 2 minus 0. So pi over 2. Okay. Now we have the two parts. So we can straight away now write negative infinity to infinity. 1 plus x squared dx is equal to negative infinity to 0 square dx plus 0 to positive infinity 1 plus x squared dx. So this is equal to, we found that is pi over 2 is equal to pi. Okay, and this is convergent because it's a finite number, so it's convergent. It's convergent. Okay, so this is type 1. Type 1 is if you have any question which is in these categories 1, A, B, or C. So we can say it is type 1. Okay, so let's move on to type 2. I will give you what is type 2, then we'll do some example. Type 2 is discontinuities discontinuous integrals. So let's see what is discontinuous integrals in the example. Let's first say A is if the function f is continuous on close bracket A to B. Remember here the B is just a parenthesis. So this means B is not included. And this f is discontinuous at B. Then we have A to B fx dx. This is equal to limit a to t, t goes to b. Here you have negative. What is this meaning? If you like in the power position, you have a negative. That what is the meaning? Can you remember in Cal 1 you did this? What does it mean? If you have a negative approaches, yes, very good. So it means approaches from the left hand side. Okay, so this is fx dx. Okay, then the second one is if again f is continuous, now on the a is not included, open close bracket, open close interval, and it is discontinuous at a. So a b fix dx. Now limit. Now this goes from t to a. T approaches to a from right hand side. This is t to b fx dx. And again, if this limit exists, the same scenario what we did. If limit is exit, we say it's convergent. If the limit is exit, we say, if the limit is does not exist, we say it is divergent. Okay. Okay, then the C is part C is, then this one, if F has a discontinuity at C, where C is between A and B, and both A to C fx dx and C to B fx dx are convergent. Then we define and to be fx dx. This is equal to a c fx dc and c to b fx dx. If both are convergent, we can say this whole thing is convergent. Let's do an example, but this means here the idea is the number point is between A and B. If f has a continuity at C, the point is between A and B. So if it is that scenario, this is what we use. Okay, let's do an example now to understand this. So the first one, 0 to 4, 1 over square root 4 minus x dx. Okay, so you will wonder it is kind of the same things what we did before. But here, can you see in the denominator, you have 4 minus x. Okay, and here you have the limit as the upper limit and the lower limit is 0 and 4. So if x is equal to 4, what happens to this integral? undefined, right? Because we cannot have, remember, we cannot, you cannot have a 0 in the denominator. You can't have a 0 in the denominator. Because if it is 0 in the denominator, that means the whole integral is undefined and it is discontinuous. We say it is discontinuous. So let's write the steps for these kind of examples. So step 1 is identify the value. Value that makes the integral discontinuous. Okay, and second is set up a limit. Set up a limit that approaches the discontinuity value. Discontinuous value. And then third is evaluate according to that. Okay, so the first step is you need to identify in which value this whole thing is discontinuous. The function is discontinuous. In this example, that point is x is equal to 4. At x is equal to 4, this function is discontinuous. Okay. Okay, so now let's write this as a limit. So if we draw, it will look like this. So this is equal to 4. So your graph will look like this. So integral means you have to find the area of this part. So what do you call this? Can you remember what do you call this line? Vertical line. Where asymptote. Very good. So this is called a vertical asymptote. So this vertical line is called the vertical asymptote. So this x is equal to 4 is our vertical asymptote. Okay. So now let's write this as a limit. So here the question is 0 to 4 square root 4 minus x squared dx. Now here x cannot be equal to 4. Okay, so then by the type 2 integrals, which one we are going to use, A, B, or C? It's A. Okay, so that means we are going to use A. So then we are going to write this as limit t approaches to 4 from left hand side, an integral 0 to t square root 4 minus x squared dx. Oh, sorry, this should be x, 4 minus x. 4 minus x. Okay, now it's just this part is just, it's the definite integral. Can you all find the definite integral of this part? Any idea what is the next step? How do we solve? Let's together we'll solve it. What is the next step? How do we solve this? How to find the integration of 1 square root 4 minus x. You could rewrite it with a, yes, very good. We can write this as a negative exponent. So this is t equals to 4 from the left hand side. We can write it as a negative exponent, that is 4 minus x to the power half, because square root is half. And then we can use the power rule, right? So we can use the power rule, and then we can write next step 0t 4 minus x as 1 and negative plus 1. And don't forget, what is the next one? This, we use power rule, but I told you if you have here a negative x, it's not just x. So what happened? What do you have to do? Remember, if you have a coefficient, we did something. What did we do? So this is not, this we get by the power rule. And also we have to do something else. If we use U substitution, because here you see it is a negative x, right? So if you use the power rule, if you have only this x is a positive one. Remember, if you integrate this is just x to the power n plus 1. If you have a negative value in front of that, remember we divide it by -1. By U substitution, but if we use U substitution here, U is negative x, right? So then du is negative dx. So that means dx is negative du. We divide both sides by negative. That's how I get this -1. You don't have to use substitution because it takes more time. So straight away, if you remember, if there is a coefficient in front of the x or a negative value, here the coefficient is -1, so you have to divide it by -1. Okay, so to get the answer. Okay, then we will have it limit t goes to f half and negative. This we will get 2 4 minus x to the power half, and it's -1. So 2 divided by -1 is just -2. 4 minus x. Okay. Don't forget, we forgot to write the limit 0 to t, 0 to t, 0 to t. Okay, so now use the upper limit and lower limit. So 2 limit t goes to 4. So here you will have 4 minus t to the power half minus 4 minus 0 to the power half. Okay. Then here you will get -2. T approaches to 4. 4 minus t to the half. Here you will get 4 minus 0 is 4. 4 to the, when you take the square root of 4 is just 2. Okay. Now what can we do? Can you all try a little bit after this? What do you get? limits. So we can use direct substitution, right? We can straight away use direct substitution by direct substitution in limit. So that means we can straight away use t is equal to 4 here. Okay, so -2, when you use 4 here, that means 4 minus 4 to the power half minus 2. So this whole thing becomes 0. So you will get 4. Okay, so 4 is the answer. Any confusing parts? Do you have any questions here? Just stop me if you don't understand in any step, okay? Up to here, are you all okay? Let's see others. Why did you scratch out the limit on the last? Oh, it's because I already here because I already substitute by direct substitution. Because I use the direct substitution, that means I already use t is equal to 4. Then you don't have to, if you use after you use t is equal to 4, you don't have to write limit again. If it's 4 minus t and t is equal to 4, then why? What was, let me check. I missed the question. If it is 4 minus t and t is equal to 4, then why would it not become? Then why would it not become? No, don't forget. T is not equal to, this means, this limit means T approaches to flow from left-hand side. So that means if you have T here, T is equal to 4, all the values are coming from left-hand side. And remember, when you take from right-hand, when some numbers are approaches from right and left, you take very close numbers, okay? Like which is closer to t is equal to 4. Oh, yes, sorry. Okay, so I hope I answered Melody. Okay, so that's why. So which is very closer to 4. So don't forget, this means it's approaches to 4 from left-hand side. It's not 4 minus. I mean, not -4. Okay, so that's why it's just 4. Okay, so we get the answer as 4. Okay, so let's do another one to understand. Okay, can I try this example? Integration 0, 3 dx x minus 1. So evaluate if it is possible. If possible. Do we get a vertical asymptote here? Is it like it's when, is there any discontinuity in the function f? Yes, very good. So when x is equal to 1, this whole thing becomes 0, right? The denominator. So that means we have a discontinuity. So the vertical asymptote is x is equal to 1. So step 1, we find that at x is equal to 1 of x minus 1 is discontinuous. So x is equal to 1 is a vertical asymptote. And now this one here, this is in between 0 and 3. Okay, it's not an endpoint. It's between 0 and 3. Then which one we are going to use? It is A, B, or C. In type 2, from here, which one we are going to use? When the denominators are more complicated, we just solve it for. Yes, Kyla. Yes, good. So if the denominators are more complicated, that means if you have something like this, let's say if you have like x cubed minus 3x or something like that, it's more complicated. You have to factor it out and check. At which points xi equal to 0? I mean, when do the denominator become 0? At which x points? And according to that, you have to find the integral. Okay, but let's do the simple ones first. Okay. Okay, so which one? So yes, I saw many answers. So we have to use the C part. C1. So that means we are going to write it as 0 to 3 dx x minus 1. Here we found that x is equal to 1 is a vertical asymptote. So we write 0 to 1 x minus 1 plus 1 to 3 dx x minus 1. Okay, now this one and this one, again, we have to use this part A and B, okay? Because when x is equal to 1, that means it's this endpoint. Then we have to use which definition we are going to use. Is it A or B? Here it is A, right? So we are going to use definition A. So t approaches to 1 from left-hand side, then 0 to t dx x minus 1, and plus here limit t approaches to 1 from positive side. This is equal to dx over x minus 1. Okay, so let's first find this and then let's find this. So let's say this is A, this is capital B. A is limit t approaches to 1 from left-hand side, 0 to t dx x minus 1. So what is the definite integral of 1 over x minus 1? So this is the definite integral now. So what is the definite integral of this? Yes, it is ln x minus 1, and then we have to use the limits, so 0 to t. Now you will wonder why we didn't use this integral before. When we had 0 to 1, why didn't we use this one? Why didn't we use straight away? Because this is also definite integral. But don't forget, even though this is a definite integral, here you see this function is discontinuous. That's why we didn't use straight away, we didn't use ln x minus 1 here. Okay, but here now we use ln because now in the upper limit it's just t. Okay, so then this will equal to t approaches to 1 from left hand side, ln t minus 1 minus ln 0 minus 1. So this is limit t approaches to 1 from left hand side. This is the absolute value of -1 is just 1. So ln 1, what is the value ln 1? This is just equal to, what is ln 1? Just equal to 0, right? So it is just equal to 0. What about this limit? What do you think you get for here? When t approaches 1 from left hand side, so that means you will get what do you think? Is it, do you get whether is it a convergent or divergent? This part. This part. Yes, good. It's divergent because here t approaches to 1 from left hand side means you get we get here negative infinity, so which is divergent. So at this point we can just stop without finding this limit because we already found one of this part is divergent. So we can say this whole equation. So we cannot evaluate, we can't evaluate this integral because it's getting divergent. It's divergent. We can't evaluate this. Okay. This divergent. Okay, so this is type 1 and type 2. And the next one is the last part of this section, that is a comparison test. This is the third one. You also have to use this one. In the homework questions, you will get some questions from this part. Comparison test for improper integrals. I did a very easy comparison test by using P series yesterday. But let's see if the function is more complicated. How do we do? So suppose f and g are continuous functions. With fx is greater than or equal to g, for x greater than a. So here now the function is, f function is greater than g function. So a is if a to infinity x dx is convergent. So that means if the integration, if the improper integration of this one fx is convergent, then we can say without finding the integration of gx, we can straight away we can say then a to infinity of gx dx is convergent by the comparison test here. Okay, and B, just a second, I don't, just give me a second. And then second part is if b to infinity of gx is divergent, then we can say by the comparison test b to infinity fx is divergent. It's not vice versa, okay? Don't get confused. So if the improper integral of gx is divergent, we can say improper integral of f is divergent. Okay, so this is called the comparison test. So let's do an examples for this. Example 1 to infinity x plus 1 x cubed minus 2x plus 2. Okay. Okay, now you see it's a very complicated question. Okay. So let's simplify this. So without so let's introduce a function if this one, if you don't have this plus 1, instead of we just have x in the numerator and the denominator without this part, if you just have square root of x cubed then what is by using the power rules or any power exponent, you know, what is the integrand here we get? So this means x to the power 1. In the denominator, we have x to the power 3 over 2. Okay, because x to the power square root means it's half. So that's how I got 3 over 2. So what is this one? By quotient rule for exponents, what is this? Is equal to. It is x to the power. Yes. So it is. So here you will get. I'll recall again. So if you have x to the power n, x to the, we can write this as x to the power m minus n, okay? So like that, you can write x 1 minus 3 over 2. This is x to the power negative half. This is the negative exponent, so we can write 1 over half. Okay, so we have 1 over x to the power half. Then can you recall from what we did yesterday? What can we say about this? Is it divergent or convergent? What is the theory that we use to find this, something like this? Can you remember? So x to the power half, okay? So there's a power. Then what did we do? P series, right? By P series, what can we say? So here we are going to use P series. So what is P series? Remember we did yesterday, if you have one lower limit and if you have x to the power P, it's divergent. Yes, because here now P is half. Okay, half is less than 1. So P series, by P series, we can say this whole thing is divergent. Okay, so if it is divergent, we can say because this function x cubed minus 2x plus 2 is greater than x to the power half, we found that this part, so this is g, this is fx. So if we find the integration, so we found the integration, the improper integration of this is divergent. This goes to integration, improper, divergent. Then by the comparison test, we can say the improper integration of this one is also divergent. Okay, so we didn't want to do this complicated function. Instead of this complicated function, we change this function to a simpler form, so that we can use the P series. So by P series, this integration is divergent, so we can say by comparison test, integration of to infinity x cubed minus 2x plus 2 is divergent. Okay. But let's do another examples for comparison test. The second one, if you have to find e to the power negative x dx. Can you all think how to use the comparison test here? Can you just try for 5 minutes? So we have to find another function, because to use the comparison test, we have to find another function, right? This is your f function. You have to find a function g. Then only we can compare. So what can we say? Any idea how to do this? Let's see. It's just others. What do you think? What is the function we are going to take as gx? X Mallory said 6 to the power -1. Okay. Okay, so I see, Mel. So you're trying your best. So let's see. So when you look at the integral, here you have a upper limit and lower limit. This means x is greater than 1, right? Okay. So that means if you divide this by a greater than 1, that means it can be 1,000, x can be 1,000, x can be 2, x can be 10,000. This is less than e to the power negative x, right? If you have just 1, this is greater than this. Okay, so we can say, now we can just find, so we can compare these two functions now. Okay, so we can compare these two functions. So instead of finding the improper integration of this, we are going to find the improper integration of the negative exponential function. What is the value of this? Is it, just tell me, is it convergent or divergent? So we are going to write this as limit t goes to infinity 1 to t negative exponential dx. Okay, so then we can write limit t goes to infinity. The negative exponent, what is the antiderivative of the negative exponential? Yes, very good. So it is e to the power, it's a negative exponential, divide by -1, because here, because of this negative x. And this one, we had the upper limit and lower limit as 1 to infinity. Okay, so limit t goes to infinity. Sorry, here it is t, just t, because we use t. So e to the power -t minus, we can take this minus in front, this negative value, over e to the power -1. Okay, so then we can write limit t goes to infinity, e to the power -t. This is 1 over e. This one is equal to what? Limit of the negative exponential. what is the value of this? If you don't remember, just look at the graph. If you draw the graph, or else you can just think of like this. Negative exponential, it is same as 1 over e to the power t, right? So when t goes to infinity, that means it's this whole thing is a very large value. So it's just 0. Yes, very good. It's just 0, because when 1 divided by a very large value, it is 0. So 1 divided by an infinity, it is 0. Okay, so then you will have as the answer 1 over e. Okay, so we had this one, and we mentioned that the larger one, this is convergent. This is convergent. The improper integration of this is this gets convergent. So then by comparison test, we can say improper integral of 1 to infinity. This is convergent. Okay, so in your homework questions, most of the questions they are asking to find whether it is convergent and or divergent. Okay, so sometimes they are not giving you which one you have to use. So make sure you do these examples. So if you have any questions, just ask me. I will do my best to answer. Okay, so this is the end of chapter 7. Okay, so I will upload, how did we know into the convergent? This is convergent because here we found the improper integration 1 to infinity. We get a finite element. This is a finite number. So that's why the improper integration of this one is convergent. Okay, could we have a determine that from P series? What is, we cannot use P series, right? Because P series means if you have the idea of the P series, if you have, if you should have the functions it should be like this, x to the power p. Okay, when p is greater than 1 or p less than or equal to 1, it depends. Convergent order. This is convergent. This is divergent. So finding your function, to comparison the function is, it's like for question to question, it's different. You cannot say this is the method to find the function g. Okay, so here in this question, so we can't use 1 over x. So, oh, you mean what? Okay, so negative x, 1 over x, 1 over x. So how do we know whether, which one is, like, how do we know which is greater? I mean, right? It's a question mark, right? We don't know whether which one is greater, which one is it. Because depending, because this graph is changing. Okay, so for some values, it might be very low values. For some value, it might be very high values. So how, if we take for gx 1 over x, we get a question mark. Like how do we know whether which one is greater than the other? Okay, that's why we didn't take this one. Okay, Kyomil, did I answer your question? Okay. Okay, I hope I answer all your questions. How did you decide what the gx function is? Confused how we get just decided to use. We didn't just decided to use e to the power negative x. We decided it is e to the power negative x according to x. Because here in the integration it says 1 to infinity, right? So this means x should be between 1 and x. It is, if you draw a real line, it's between x values are here, between 1 to infinity. Okay, so by this, we know x is greater than 1 by this part, by the integration part. So that's why I chose to this question. When you have this function, so x is greater than 1. X can be 10,000, x can be any number. So when you divide a number by a very large number, this whole number become less, right? Because here you see, if you divide by 10, and if you divide by 10,000, there is a huge difference. Okay, when the denominator is very large, your whole fraction is getting lower. It is less than this number. So that's why I chose this is less than e to the power negative. If you just have 1 and this is greater than 1, it's definitely this whole thing will less than this function. That's how I got the function to this question. So do your homework, you will see like how to get the g function. It's question to question, it's different. Okay, so for this part, you have to practice more to find the other function. Okay, Emma, wow, was long. I hope I answered all questions. Okay. Okay, so let's move on to chapter 10. So this is end of chapter 7. I will upload the review, exam review for this chapter 7 today. So chapter 10. So the first one is 10.1, curves defined by parametric equation. So is the exam this Friday only? So today's Tuesday. You will get chapter 7 and this part 10.1 for your exam. This is for exam part. Okay, because today is Tuesday, I can cover 10.1 by tomorrow. So you will get chapter 7 and 10.1 to your exam part. Okay, so curves defined by parametric equations. So this you haven't done in Cal 1, so this is new. So let's see. So if you have the coordinate system, okay, and if you have like a curve, say this is curve C, we cannot write an equation for this curve C. Why? We can't write an equation y is equal to fx for curve C. Curve C. Why? Because in Cal 1, we did to be a function in the graph. Whenever a graph is given, you have to check whether it is a function or not. To check whether it is a function or not, we use the vertical line test, right? So if we use the vertical line test, it fails because here you see, if you draw a vertical line test, it cuts more than 1 point. So then it is not a function. Okay, so why? Because this fails vertical line test. Vertical line test. Then how do we write an equation for these curves? That's the question we have. Because we cannot write it as y is equal to fx, because it's not a function. But how do we write a curve C as an equation? So let's say this is a point x and y. This each coordinate, so this is like a particle, so particle is moving. Okay, so this particle, we can write the position of this particle according to time. Okay, so we can write each coordinate in terms of time. Let's say this is ft, and y can be written as a function of g of t. Okay, so this is called a parametric equations. So I'll write it, but x and y coordinates are functions of time. That is, we can write these coordinate in terms of t. So this is f of t and y is g of t. Here t is a parameter. And then we call this whole equations, that is x is equal to f at t and g is equal to f at t. This is called parametric equations. Okay, so now in this part, we are going to learn how to draw these parametric equations. When they will give you parametric equation, you have to find how to draw the parametric equation. So let's do an example. So graphing parametric equations and eliminating the parameter. So let's do an example. So the first one is, let's say x is equal to t plus 2, y is equal to t square. And t is between -2 and +2. Okay. So best way to draw parametric equation is by drawing a table first. Okay, remember when we draw functions, like if we want to find y is equal to 3x, first we draw a table and we apply some values for x and we found the values of y. Okay, so same thing, but here now you have 3 variables because here t is also there. So you have to draw a table with 3 variables, t, x, and y. And according to t only, we are finding what is the value of x and what is the value of y. Okay, because t is changing. So t is between -2 and 2. So let's start from -2, -1, 0, 1 and 2. Okay, so can you tell me when t is equal to -2, what is the value of x? So we use this equation to find x. And to find y, we use this equation. Okay, so when t is equal to -2, what is the value of x? 0, yes, 0. Then what is the value of y? 4, yes. So like that, we can fill the table. So when t is equal to -1, this is 1, this is 1, here this is 2, 0, 3, 1, 4, 4. Okay, so now let's plot the graph. Now when plotting the graph, we don't worry about t because we already considered t. Because according to t values only, we found this x coordinate and y coordinate. So don't worry about t. So graph these points, so 0, 4. So this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Can you draw the graph? 0 and 4. Can you draw the graph and show me? Kyla, yes, good, Kyla. It's not clear, Ma. I think it's because your camera, but it's good. Yeah, good. What about others? Miss? Yes, good. Okay, let's see. Yeah, I can see William. Good. Yes, Emma, good. Yeah, it's a parabola. It should be a parabola. Yes, good, very good. Yes, very good. So you are participating in the class by doing well. So yes, so let's draw the graph. So 0 to 4, 0, 4. This is here. 1, 1 is here. 2, 0 is here. 3, 1 is here. 4, 4 is here. Okay. So if we draw the graph, it will look like it's a parabola kind of thing. Okay. Okay. Now, so it's the normal, yeah, yes, Melody, good. So it's a normal, yeah, okay, it's a normal graph, it's a normal. But in parametric equations, the difference is now you have to find the direction because parametric equation means it's a particle is moving. So you have to find in which direction the particle is moving. Okay, so to find that, I'll just give a note first. Note. So a particle moves along the curve in the direction of the arrow. So we draw the direction by arrows as t increases. So now you have to check in. So here, let's say. So this point we got when t is equal to -2. Okay, and this we got when t is equal to -1. And this we got when t is equal to 0. This we got when t is equal to 1. And this we got when t is equal to 2. So let's just consider x. So here, when t is increasing, because when t is equal to -2, when t is equal to -1, when t is increasing, what happened to x values? Is it increasing or decreasing? By looking at the table, can you tell me? So this means from here to x increases. Okay, so x increases. So that means, so always your arrows should be draw from when t is increases. So from left to right, t is increasing. So your arrows will look like this. This. Okay, so this is your parametric curve for these parametric equations. Okay, so the first one, what you have to do, you have to draw a table and find the values of x and y. And then according to x and y coordinate, you have to draw the graph. And then the next step is the different part is you have to draw the direction of this particle. How do we find that? In the direction where t increases, you have to draw the arrows. Okay, so t increases, when t increases, x increases, so the direction is this side. Okay, so this is one of the example. So let's do another example. Now can you try this one by yourself? X is equal to square root t, y is equal to, do you all have any question? 3t plus 1. Okay, can you all, okay, so t is greater than 0. I'll write the table t, x, y. Let's get some easy values for t. T when t is equal to 0, when t is equal to 4, when t is equal to, sorry, when t is equal to 1 also can, it's easy. When t is equal to 1, 4, 9. Can I find the x and y values? Complete the table and draw the graph. You want us to draw the graph? Yes. Draw the graph and also the direction. But t doesn't have to, no, t doesn't have to be always greater than 0, but here it should be greater than 0 because of this equation. Okay, because square root t means if it is a negative value, then you get complex values. Okay, so because of this equation, t should be greater than or equal to 0. Okay, just wasn't sure about how that works. So, okay. Okay, so when t is equal to 0, what are the values? So it's just 0, 1, 1, 4, 2, 13, 3, 28. Yes, yes, good, Kyla. Emma, just little bit this side. Yes, good, good, Emma. Yes, good, good, Emily. Yeah, very good. What about the direction, Kyla? Yes, yes, Kiyomi. Yes, good, good. Yes, Brady, can you show it again? I didn't see. Yes, Lenny, good. Len. Mallory, yes. Yes. Okay, I think it's fine. Brady, I think it's because of the light, I don't see it properly. Okay, so let's draw it. So when you draw it, you will get y coordinates, you get very large ones. So I will not draw all the points. So, but you will get something like this. So 0, 1. So here, and 1 to 4. So you will get something. You will get something like this. And now you need to check the direction. So this point you will get when t is equal to 0, when t is equal to 1, when t is equal to 4. And now you see it's increasing. The values are increasing. So your direction is this side. Okay. 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 Sometimes, so here what we did is when the parametric equations are given, we draw the table, and according to that, we draw the graph. In some questions, they will ask you to eliminate the parameter and then draw the graph. Okay, so this is this. So eliminate the parameter to find a Cartesian equation of the curve. So let's do an examples for that. So 3 is x is equal to 2t minus 4, y is equal to 4t square. Okay, so you need to eliminate parameter t. So eliminate t. How do we do this? Any idea how to eliminate this t here? Any idea how how to do this one to eliminate t? Remember, we have done in I guess in college algebra, elimination x, elimination y. It's the same procedure. How do we do that? Solve for t and yes, very good. Solve for t and replace um, replace that. So let's say it's easy to solve this one, right? Because it's a linear equation. So let's solve for t in this, for this equation. Solve for t. Then we have a value for t, and that value we are going to substitute for this. T for this. That's the idea. Okay, so let's solve for t. What is t? So x is equal to 2t minus 4. After solving, can you tell me what is t? X plus 4 over 2. Yes, William, very good. So we need to get rid of this 4. So you x plus 4, then you have 2t, and divide both sides by 2. Then we will get a value for t. So t is equal to x plus 4 over 2. Okay, then we can use this one to y is equal to 4t square. Okay, so what is the y value then? X plus 4 squared to, what do you get for y? Y is equal to x plus, yes, good, x plus 4 square. Okay, so this is, now this is the normal equation, you know, right? This is y is equal to x plus 4 square. So we can, so now you need to graph it. Okay, we can use, you know, to find y is equal to x squared, right? The graph of y is equal to x squared. That is, the basic graph of y is equal to x squared is a parabola. Okay. Now here you have x plus 4. Then what is this? It's a transformation, right? So is it a horizontal shift or a vertical shift here? When you add x plus 4 inside, so this is a, let's see if anyone, horizontal shift. Yeah, it's a horizontal shift, and horizontally it shifted by 4 points, because here it is plus, it's going to the left hand side. Okay, so it's a left horizontal shift. So if we draw, so here x is equal to negative 4. So this is your graph. Okay. But what is the difference here? Here, if you stop here, there is no difference, right? We just draw the graph of y is equal to x plus 4 square. But we need to know, because it's a parametric equation, we need to know the direction. Okay, in which direction the particle is moving. So for that, we need to know the t value. So let's find that. Now we need to know the direction. We need to know the direction. So we need to find in which path the t is increasing. So let's find by this equation, x is equal to 2t minus 4. So here when t increases, what happens to your x value? By looking at the graph, can you all tell me, when t is increasing, what happened to x value? Is it increases? Yes. So when t increases, x increases. Why? When t is equal to 0, x is equal to negative 4. When t is equal to 1, x is equal to negative 2. When t is equal to, let's say, 3, x is equal to 2. So it is increasing. When t increases, x increases. So that means this is the direction. Okay. Okay. Uh, what about, I have a, um, I'm thinking, okay, let's do this question. X is equal to square root t, y is equal to t minus 1. Eliminate t. Add t and draw the graph. Can y'all do this now by yourself? And draw the graph and show me, okay? I see Emma. Okay. Okay. Emma, uh, so here you have to consider about uh, he should be there should be a restricted. The graph is restricted here. Can you think a little bit? Graph should be restricted because here, because of this equation, x is equal to square root t. Remember, I mentioned this in a previous example. So t should be positive, right? See, t should be positive, then x values should be positive. Okay. Let's see. Oh, I'm sorry, Emma. Uh, little bit, go back little. Uh, yeah, I think, yeah, it's correct. Yes, Em. Okay. Let's see, Emani. Okay. I think Emma, call it. Did you consider the restriction? Did you restrict the graph, Emma? There is a restriction of the, okay. So yes, the domain star. I have two Emmas. Both have the same mistake. Let's say Mallory. There is a restriction of the graph, Mallory. Just check because t should be positive here, right? Because of the square. Riley, yes, good, good. Emma, yes, good. LeBlanc, yes, good. Grave, yes, good. Kyler, I can see the graph, Kyler. Yes, good. Okay, so let's see. Emma, yeah. Good. I see everybody is now correct. Yes, Alex is good. Okay. William, yes, good. Kiomil, again, there is a restricted of the graph. So domain should be a restricted domain. Yes, yes, good. Kiomil, yeah. Okay, so here, let's draw the graph first and then talk about the restriction. So first eliminate t. So we can eliminate by this one, x squared t. So we have t is equal to x squared and just substitute for this so that we will get y is equal to x squared minus 1. Now this is a vertical shift. Why? This is the basic graph of x squared. Because of this negative one, so this means it's a vertical shift. Vertical shift. Y is equal to x squared minus 1. But we have to consider, we have to check whether there is a restriction or not. Here, so but we have restricted domain y because of this parametric equation. Here t should be greater than or equal to 0. So that means t is between 0 to positive infinity. So that means for x also you will get x should be between 0 to positive infinity. That's how, that is why it should be restricted. So then your graph will look like something like this. Okay. Okay, but we are not done yet because we need to find the direction. So here this is when t is equal to 0. And when t is equal to 1, you will get this point. So that means when t is increasing, your x value is increasing. So the direction is in this side. Okay, so this is your final answer. Okay, so to finish this section, we have to know, because in your homework question, you will get something, some equations like this. That is when x is equal to 3 sine t, y is equal to 3 cosine t. But this is kind of like let's do this tomorrow because you have to think little bit and I don't want to do that today. So let's do these kind of examples tomorrow. So this section, it is examinable, and these kind of questions are the questions that you get in exams questions. Okay. Okay, so let's stop here. If you have any questions, you can stay. Others, see you tomorrow. Okay, thank you for coming to the class.
Would you tell us a little bit more about the test, like how it's going to be structured, like question wise, or like how it's going to look, or?
So how you will see, I will give you the review. So the review will be same as your exam time. Like the paper it will look like the revision. So when I send you the review, you will see how does it look like. Okay.
And then also, do we get an equations sheet? She just asked in the chat.
That I have to think a little bit. Let's see. Let's see. I will tell that about today.
Yes, ma'am. Okay, thank you.
Okay, you're welcome.
You have a good day.
You too. Okay. Have a good day, Colby.
Where
Yes,
is the
Emily.
exam at?
It's online.
Oh,
Like
it's
you
online.
do it. Yeah, it's online. Well,
It's
like
gonna
you
be
do
through
it.
Moodle.
Yes, Moodle. Like you submitted in the like quizzes you submitted, it's how it is, it looks like. So I'm looking at y'all doing the exam, and after the exam time, you submit in the mode. That's how you do it. You
Okay.
take pictures and submit in the module.
Okay.
Okay.
I had some questions about a few of the homework problems, if you have some time.
Yeah.
The first one was 7.2, number 9. Let me see.
7.2, number 9. Do you have I'll allow you to share the screen so that you can share the screen.
Okay, let me just pull it up real quick.
Just a second. Can you check whether you can share the screen?
Yes, I should be able to. I'm just trying to pull it up first.